In this session, we will revise all of the formulas we saw in the last two lectures as a short and summarized cheat sheet. So let's start with the lead time demand. And as I mentioned, lead time demand is just your demand of inventory during the lead time. So it is given by the product of lead time times demand. Next, let's look at the standard deviation of lead time demand. And the standard deviation of the lead time demand is based on the variance of lead time demand and lead time and demand, and it's given by square root of sum of two factors, the variation in lead time and the variation in demand. And the variation lead time is just lead time times the standard deviation squared of the demand, and the variation in your demand is just demand squared times the standard deviation squared, or the variance of your lead time. And then we have the safety stock, which is basically the product of the standard deviation of lead time demand with a service level or a constant factor. And basically, as I mentioned before, we sort of consider the variation in the lead time to make the model simpler to be 0. So these terms cancel out, and we are left with this term, which is basically equal to this part here. And this z value is just a constant, or is based on the probability distribution of your service level, and is taken generally at about 1.65 constant factor. So safety stock, as the name suggests, is simply the safety net you have against the variations in your lead time or your demand, basically. The reorder level is the product of lead time mean and the demand mean, and the sum of the safety stock, which we have found in the point number 3. And your reorder quantity is given by the relationship of square root of 2 times your fixed cost of ordering things times annual demand divided by the holding cost. And to explain things further, I would like to take some few examples of each of these points with illustrative examples. So let's take lead time demand, which is the product of lead time times demand. So in this case, if your lead time is 5 days and your demand is 100 units during the period, so your LTD will be equal to 5 times 100 equals to 500 units. For your standard deviation of lead time demand, if your lead time is 4 days and your standard deviation of demand mu of t is 15 days, sigma of t, and standard deviation of lead time is 2 days, and your demand is, let's say, 50 units per day. So if you plug all of this, and the standard deviation of lead time demand is what we want to basically find, which is given by this formula. So if you plug these values into this particular relationship, and this comes about this particular relationship. So if you plug these values, it's 4 times 15 square plus 50 square plus 2 square, 50 square times 2 square, and this product, and you take the product of these two values, these two parts, and then sum it together, and the result comes out to be approximately 104.4 units of standard deviation of lead time demand. And next up, let's look at the safety stock. So if you have these values, your service level is, let's say, 1.65 based on the 95 confidence level estimate. Basically, this is based on the uh, probability distribution of the z tables, and standard deviation of demand, let's say, is 20 units and lead time is 9 days. So if you plug all of these values into the safety stock, you will get this relationship: 1.65 20 times square root of 9, which comes up to be about 99 units. Similarly, if we do it for reorder level, the same concept applies. So we have the product of lead time, so it's lead time times demand, plus we have the component of safety stock, which is basically your z-score times standard deviation of demand times square root of lead time. And let's assume we have these values. So lead time is 6 days, demand is 200 units per day, z-score is about 1.65, and the standard deviation of demand is about 25. So we plug all of this into this formula and we will get an amount of about 1320 units. And you can see that using these simple models, you can actually apply them effectively to a large set of inventory. And typically speaking, these parameters are generally managed in a inventory management system or an ERP system, where they are programmed to be used across different kinds of items. And one last point I want to make in the conclusion of this lecture is how basically these parameters are actually managed in the real world, to the point which I alluded to earlier in the lecture. So let's quickly look at what is the workflow by which we generally use these parameters in, let's say, a large enough industry or a inventory, let's say, managing more than 500,000 SKUs or different kind of items. So let's just create a very simple workflow for that. So let's just think about it. So first thing is, you have your historical data. So let's say you will have your historical data sets based on your last year, or basically multiple year of transactions from the last years. So we have our data sets from the last years, and what we do is basically we run it through a the normal distribution model, which can generate the mu and sigma, or the mean and standard deviation values, for each of the SKUs or for each of the items. So for example, let's say we have the structure of the data set as follows. So we have, let's say, this is our SKU, or our stock keeping unit, and this can be such as any item. Let's say the transactions from the last year, so this is maybe 101, and we have the transactions here such as issuances or customer purchases, or maybe this item is used in some production process, etc. So let's say we have for multiple months, so we have maybe 100, 110. So this can be for January 24, this is February 24, and so on and so forth. So you would take this data and you would put it in a model which can generate the mu and sigma for this, but for each of these items. So let's say this is 102, 104, and so on. So it will take this information for the transactions as a vector and produce these. It will model it on a normal distribution, let's say, and it will produce sigma and mu and sigma, and then you can use these parameters into your into your set of calculations, which we have just seen here on my right side. So these are my calculations, and then you can put that part into your ERP system, for example. So for example, this can be something like SAP or a similar sort of system, and this will be like a closed loop system. So the idea being that from the historical data, we'll model these into normal distributions with certain mean and standard deviation, and then we will do the calculations so that our inventory would always be in control based on the last observed transactions.